my name's Chad Schmidtke. I'm the Director of MapleSim Development, and I want to just go over some of the new features that are in 2015, as well as introduce a sister product to MapleSim, and that is MapleSim Server. It's essentially a technology that allows you to interact with MapleSim's engine over a web page. So you can distribute the analysis for a MapleSim model either on your local company's intranet or more globally. So without further ado, I'm going to skip over directly to what's new in 2015. So starting on the engine side, this is something we're very excited to announce, that MapleSim 2015 now ships with the Medelica Standard Library 3.2.1. This is the latest version of the library, and I'm excited to say this for two reasons. One is it continues to show our progress and commitment to this standard in supporting sort of the subsequent and now the latest version of the library. But secondly, it's nice because a bunch of our users can get access to some additional components that are included in this library. Particular highlights, I've just listed a few here, are the quasi-stationary motors and blocks for electrical power analysis. If you're doing steady-state analysis and don't care about transients, you can do some powerful analysis in this domain. There's some updated motor models. These include a variety of types of frictional losses or stray losses you may want to include in your modeling. We've also made some additions to this library where we've updated all of the signal blocks, so they now can act on vectors as well as simply scalars. Just makes things easier to use. So sort of in summary, on engine side, the big change in 2015 is that we're using the latest version of the MSL. There's new components, and the components have been improved because the library's been updated. On the user interface side, the real focus has been on larger models. And of course, if you make it easier to model and interact and interrogate larger models, it's easier for the simpler models as well. So we think that this will benefit all of our users, but particularly those who have more complicated systems. The biggest of these enhancements was a searchable model tree. So now you can go to the model tree, start typing in. You can specify if you're looking for a parameter or component type, and start typing in the name of it, and it will immediately search through the entire model and start highlighting where that occurs, and it'll give you sort of a listing of that in the tree of where that occurs, where that parameter occurs. You can click on it and it'll take you directly to that location in your model. An excellent tool for quickly navigating through or finding something. If it's been a while since you've been in a model and you know you used a block somewhere, you can hone right where it is. We've also updated the parameter inspector. This is the piece of MapleSim that allows you to look at a particular, the parameters for a given component. It will now, if you select multiple components, allow you to sort of intelligently look through those parameters, and if there are any parameters in common, it will still show them parameter inspector, and you can sort of batch update that for all the components. So if you want to make a change to a bunch of motors simultaneously, change a gain on a controller, you can highlight them all and change the gain once, and it'll propagate to all of those components. Another nice feature is a diff tool. If you've ever been in the situation where you have made modifications to a model and you have different revisions of it and you don't remember what you changed, this is the tool for you. Previously, what you needed to do is export the code to Medelica and then use a textual diff tool to be able to give you information or feedback on what was different between the models. This would, of course, tell you what was different, but it wouldn't allow you really to pinpoint the change. You could find line changes, or if the Medelica was modified in some other way, it can be hard to track where the actual change was introduced. With this tool, you can now just take two models, ask it to compare them, and it will give you a update sort of looking at the model tree itself, what has changed. So it'll tell you exactly, oh, this parameter on this component has been modified. The final little piece, again, these are all sort of small updates, but when you add them together, it makes the overall experience of modeling, particularly with larger systems, easier inside of MapleSim. The last update is a collapsible message console, and here we've, again, particularly for large systems, but it's true for all, the message console simply kicks out what the engine's doing at any given time. And what we've done is broken that into collapsible sections so that after a certain phase is done, you can go back, open it, find what you're looking for. If you want to know if there's what the multi-body coordinates were or your Tarzan block structure, you can go back and look through that output and find it more directly. So some other requirements that are listed here. that we've added to the product but don't really fit in a specific category, you can now fully leverage your machine's resources on a 64-bit Windows machine. Previous versions of MapleSim shipped with a Java engine that limited you essentially to about 1 GB of RAM for your models. That restriction's been removed in 2015. You can also, in MapleSim 7, we had provided a results manager that allowed you to sort of customize plots and save those plots in analysis for a MapleSim model. So we've improved that in 2015, and by customer request allowed you to call it directly from a Maple worksheet. Some of our users use Maple worksheets to interact with MapleSim engines, the MapleSim engine, and they requested that they could just save the results directly to that results manager and then launch it from Maple. And finally, we also introduced in 7 a user library feature, and we've enhanced it again. This is by user request. You can now, any custom components where you go into MapleSim and you've got a custom component where you've written equations inside the Maple worksheet, those worksheets will be transformed into HTML and included automatically with the help for a user library. So when you give it to a colleague, or even for yourself when you're using that library later on and want to look at the help for it, you'll be able to see that, and you'll be able to see the actual equations written rather than just sort of the printout of the underlying Modelica code. One thing that isn't part of sort of the MapleSim engine proper, or the MapleSim tool proper, is the out-of-box experience. And this is something we've tried to improve to make it easier for people to get up and start running with MapleSim. So now you'll notice that the startup screen, which you can get back to later on, has been changed. And I'll maybe just pop over to it. So I can call it back up here if I go into Show Startup Dialog. This pulls up the new resource screen, and if I click on any of these, basically these all link to, for the top 2 sections, simple videos that cut to the point on, okay, basic modeling. How do you do that in MapleSim? Simulation. So it gives you quick resource or access to resources. And if you click on any of these links, you'll see a page, describes certain things you might want to find more on, and also a simple video that walks through how to perform some of these basic tasks. The bottom row of pieces there are just information and where to get it. So it's a nicer way for users to get started. You'll see more changes and improvements to the sort of user just starting with MapleSim in 2015.2. But this release we've started with making these resources more available to you when you're using MapleSim. So let's take a look at some of those other pieces. This is a model of a walking now robot. I'll just let you watch it doing some walking at first here. He would drop him onto the ground, the contact model, and just starts walking. So this particular case, we've told him how he's supposed to walk, and he's walking along the floor. I show that mostly because it's fun to watch the robot walking. But it also provides a cool example for me to show some of the new features. So let me go over to that model tree that I was talking about. This is a model tree that basically lists all the components inside. And if I suggest that I'd like to look at some parameters, here, let me show you some of the parameters used in the model. If I want to know where these parameters are used, so for instance, who's taking advantage or using the tibia. So there's my tibia length parameter that I just looked at. If I right click and say find references, MapleSim will go off. It'll search through the model for all the places that's used and give me a listing. You can see them appearing in red here. If I click on it, it'll take me directly to, in this case, the Denevet-Hartenberg block where this parameter is being referenced. So I can find out immediately how this appears or is used in my model. Obviously, you can see the drop down here. I could search for component types or components in a similar fashion. One other thing I mentioned was the ability to select multiple parameters and change them. And so here you can see I've selected 3 of these blocks, and it says for alpha and theta mixed. And that just means that these parameters have different values for the different blocks. But if I were to enter a new value, say 3 for these, it would come up, and now if I were to click on these, you can see that the alpha has been updated. Let me save this model as a second version of this. So I'm going to save it to file, and then I'm going to open the original model that I just had there. Great. The diff tool allows me to take these 2 models, compare them. You can see it immediately comes back and you can see what was modified. that 0.5 pi was all modified, and also the model that I was using had a stored results, so some attachments there. So immediately the diff tool tells me this is what was changed in your model, and you can get to it right away. Searching through this to try and find the change would have been much more difficult. The last thing that I had mentioned in the What's New that I just want to show you here, mostly this is for something for you to explore yourself. You can see we've added the complex blocks. These use real and imaginary units, depending on the type of analysis you're using. The quasi-stationary blocks that I talked about, and the updated motors, the quasi-stationary as well as the motors with friction parameters. There's a few other blocks sprinkled in throughout, and the important thing is that behind all of this we're using the 3.2 library. So the add-ons that also got modified, there's a Maplesoft Battery Library. Two big things there. We've extended the number of cathode and anode chemistries. These are constantly being updated in the research and literature. So we've added some additional chemistries for users to use. Also, previously in 7 when we launched this, there was the ability to create a user-defined state of health or battery degradation effects, where you would define how the capacitance of the battery is changing as a function of time, or the state of health is changing. We've now also added a sort of a de facto or a default state of health that you can just use. You don't have to create your own. It allows you to get up and run quicker. There's some parameters. It's a standard model for this, so people can just start using state of health right away without necessarily having to build that model themselves. We've also made some updates to the FMI connector. For those of you who don't know, FMI stands for Functional Mockup Interface, and this is an exciting new open standard that's starting to enter the modeling community. Essentially, it's a way of sharing models. So you can package a model up, and because it's an open standard, any other tool can grab that package and bring in your model and run it as part of their simulation. MapleSim is highly effective at generating very efficient code, and so we've paid a lot of attention to this standard, and we currently have an exporter for the latest revision, the 2.0, FMI 2.0. That was released in 7.0 or 7.01. We've updated the template for generating this just to make it easier for interacting with other tools. So we're still exporting the 2.0 with some efficiency tweaks. Obviously, it's the next version of the connector. But the biggest changes have gone in how you can tweak the template. So now you can define if you want a prefix before certain inputs and outputs. Some tools that import these FMUs, we call them, some tools that import them look for certain things on the input, and that's how they end up mapping them to their inputs in their model. And so if you can just do this on the template when you export the FMU, you don't have to do any modifications in the target tool. So it's really some ease of use pieces we've done here, but it goes along our goal of making the really fast and efficient code available from MapleSim to more and more tools in a more efficient manner. So the last thing I wanted to talk about today is the MapleSim Server. And as I said before, MapleSim Server really is just another way of getting access to MapleSim's engine without necessarily having to have MapleSim installed on your desktop. So it's easy to deploy. You save a worksheet that accesses a MapleSim model, and you can immediately just transfer that to the web server, and boom, you can access it over the web, your internet, or however you have it set up. There's no additional license fee for usage. You pay for the MapleSim Server license, and then as many people as you want can be accessing it. There's no MapleSim install required anywhere on any other machines. It's for people who want to do that to manage version control. Obviously, if it's on the web or it's coming off a server and it's deployed in that manner, it's only got one source file that everything's accessing. So the way it works is pretty simple. You've got a MapleSim model. You generate some analysis in the worksheet, so you've created some sliders and things that interact with the model, generating plots. That just simply gets transferred. That model, as well as the worksheet that interacts with it, gets transferred to the server. And now somebody can pull up on their web browser that worksheet that you created that's sort of referencing the MapleSim model. And data just goes back and forth between the two, and it's updated. Now, sort of the cool thing about this is that it's using HTML5. What does that mean? means it can work on all kinds of devices. So here's a BlackBerry where you can see that worksheet up and running. You can also use, we've tried it with iPads. Anything that supports HTML5, it'll work in that browser. So mobile devices can also access these things and interact with these MapleSim models. You want to check what happens when you change sort of the, well, I'll show you a highway driving example. So let me just show some simple models. Here's an electrical vehicle, lithium-ion battery. So here I've clicked on a link, and now it's showing on our MapleSim server sort of test server that you can take a look at. It's a model that's got a battery set. You've got some steering conditions as well as a drive cycle. So a given velocity you want the vehicle to go. There's some braking, so you can do regenerative braking. It's got a motor that's driving, sort of electric motor driving the rear end axle, and you've got some drag effects going on. And you can see what happens. You can allow it to sort of change gear ratios, vehicle weights, the area of the car that's going to affect your drag, things like that. You can also change the drive cycle, whether you've got a highway or a city drive cycle. So you can see the highway drive cycle, this thing's running, the battery's just discharging. If I update the results now that I've changed this is back end. What's happening is there's a compiled MapleSim model that's being fired off, and it is running the background on the server, generates the data, and sends the plots back. And so you can see the updated drive cycle here, as well as how the battery is charging and discharging as you're braking. We've also got another example here, just Fourier transform, but mostly what you're looking at is multiple components connected with springs and dampers, and what the frequency domain analysis as well as a time domain analysis for that. And again, you can see if I crank up the damping, you can guess what's going to happen. My model's going to have much less fluctuation, and it'll tone down and damp out much sooner. So you can play with models in this way. This is great not only for industry customers who may want to, in a way, deploy information or intelligence to other people to say, hey, we've got this worksheet that you can do to analyze certain things, play with it, take a look at how you're sizing a particular bearing or something like that. But also for academic users who want to use something like this to help engage students for different kinds of analysis and models. This is a really cool feature that makes some of the worksheet analysis that people do just available to anyone, and we're quite excited to be launching this.